Thank you, everybody, for joining. My name is Nicole Spear. I'm with the IMEDS team here at Reagan-Udall. Like I said earlier, the phones have been muted just to cut back on background noise, but like we normally do, I'll unmute it at the end for questions and answers. Before I get started, just a quick update. I wanted to let the group know that this month and next, IMEDS is participating in a few conferences. So if you'd like to see where we're going to be, we posted a list to the front page of our webpage. With that, I will turn this over to Mark Khayter. I'm sure many of you know Mark. He is our lab director, and so if you work in the research lab, I'm sure you've interacted with him on a number of occasions. He's going to demonstrate a new cohort building visualization tool that he's been working on. And I'm not sure if this is currently available in the lab, Mark, or if this is something coming, but if you wanted to give us maybe just a few words on that as well.
Yeah, I'll mention that in a second. Yes.
Okay, great.
Good morning.
All right. Go ahead.
Thank you, Nicole. Good morning, everyone. My name is Mark Khayter, and like Nicole mentioned, I'm a director of research lab at IMEDS, Reagan-Udall Foundation for the FDA. I'm also a partner at a company called Khayter Incorporated. And today we are going to have a discussion about visualization of cohort creation. And this is the product that we put together just to simplify and ease the process of creation of the cohort for a number of people. So with this, we'll start. It's just going to be a couple of slides, so bear with me. I'm not going to be throwing a bunch of slides at you. Most of the presentation will be on the live system. So it makes me obviously a little bit nervous that everything is going to work perfectly in front of everyone here. But here's what we'll start with a couple of slides. So what is evolution of cohort creation? So if not that long ago, prior to Common Data Model or CDM, people used to create cohort out of the source data. And source data is different from one source data set to another. It will have different field names, different structure. Some of them will be claims data, some of it will be EMR information, and it requires knowledge and information provided to the developers on the structure that will be against which cohort will be created. So it requires people with the knowledge of SQL and SAS to perform for each individual data set a separate program to create to define what the cohort will be. What the result of that is it requires two people practically, someone with a clinical knowledge who will define a study, and then second person, usually it's a technical specialist who will have SQL, SAS, or R, or some other languages to define study using some programming language and execute. This results in a long duration process of creation of such a program. And obviously it's costly. You have number of people involved in the process. You have technical people who are not necessarily have all the clinical information knowledge, and clinical people who don't have necessarily technical knowledge of how to execute. That's also resulted in some mistakes that people will make because it's translations between the two groups. About 5-6 years ago, common data models started appearing. And this includes OMOP, CDM, and then shortly after, Mini-Sentinel. Now we have Picori CDM. They provided a lot of benefits for the people. So for one part is it created consistent structure for the people. They will know where the drugs are stored. They know where the observations, where procedures and conditions, demographics information, what's available for the person. That translates into consistent SQL. So we can write a SQL program that will run against one data set and execute potentially on the same DBMS, the same program in very consistent manner, getting results. So it reduces the cost drastically. It still requires porting of the SQL to different DBMS. So if we will execute on Oracle program, it might not work exactly in the same way in Postgres or SQL Server. So it requires tweaking and modifications of the structure of the program that obviously increases the cost of operations. It also requires SQL and CDM structure knowledge. So people who will write this program, they have to know more about where the data is, what is the structure of it, how it will be translated, the codes or vocabularies, for example, from ICD-9 to SNOMED, what information that they will be looking for. That's still people sit in front of the terminals writing SQL code and verifying their programs. The third part of evolution, the way I see this, is visualization of cohort creation using CDM data structures. And that evolution provides opportunity for us to eliminate knowledge of SQL. For the people who will be performing such operations, they can be performed by clinicians directly without knowledge of underlying structures of the DBMS, of the CDM itself. And it's SQL that generated behind the scenes within applications should be DBMS specific, independent from DBMS. So it doesn't matter if you will be executing on SQL Server, Oracle, Postgres, or any other type of DBMS. The other thing is that it does not require people to have knowledge about CDM structure. So if we working today with OMOP structure, it's one structure. If we do looking at the Sentinel or Picori, it's a different structure. There are some similarities in the information between them, but there's also differences. And those differences should be hidden from developers or from clinicians who are performing operations of creating cohorts. So with this, I'll just show you quickly one slide of what is our representation of the data is for the people that will be seeing what will be visual representation looks like. In this case, I'm showing you COPD study that defines list of the medical conditions, drugs, procedures, maybe demographics information. And on the right side, you see execution of the results. So you see for each category information, you see information of how many patients have been found within each individual grouping. If you notice, there is also information about entries that have been performed by the users. So we can enter information directly as ICD-9 codes or GPI for the drugs or some other or RX norm information based on the knowledge that clinicians have within their possession when they're defining the study. It is not, they don't have to know what is ICD-9, how it maps internally within OMOP. We'll try to eliminate need for this kind of knowledge information which will be possessed by technicians. And with this, I'm going to move to study definitions. This is actual application that's running right now. So this is COPD program that I put together as was shown on the slide. The process is relatively simple, at least for me, definitely. But I think it's easy for you to understand and read this. So we're defining lists for definitions for drugs, conditions, procedures, and observations where we can identify that the person has COPD disease. In case of conditions, we can identify them based on ICD-9 codes. In case of drugs, there could be more complex structures of different types of drugs, set of procedures, observations that can indicate that the person has COPD. I also added some demographics just to demonstrate what that is, how we can identify a smaller group within the COPD cohort. And also I created comorbidity for smokers and BMI. With this, let's take a look at what is the process of definition for ICD-9 case, in case of ICD-9 conditions. The users usually, and when I talk users, I'm thinking of clinicians, people who have knowledge about clinical data. So they know ICD-9 codes. So they can type in directly ICD-9 codes that's applicable to them. In order to verify that the codes are correct, they can see, by clicking on Show Results, they can see a list of the concepts that translate these codes. And we can see that it's pulmonary disease, chronic asthmatic bronchitis, and so forth, asthma with asthmatic. All of the diseases we can verify right here on the screen that is produced properly. There is two options on the list. We can do OR, meaning that identify the patients who have any of the items included within the list. Or if you will do AND as an option, we can identify that only patients who have all of the items within the list will be included within our set. This can be the case when we will say, give me the patients who have both COPD and diabetes, so combination of diseases. I would like to study only those type of patients. We are not hiding anything from the user, so if they are a little bit more technical and they would like to see some information in more detail, they can click on the SQL that's being generated for this list, and they can see what, in this case, for OMOP CDM4, what the list will be represented. And you can see that you can select that list and execute within your queries to play with it and see how it works there. If you're not happy with your concept list, you can take it out, create a copy of this in an Excel spreadsheet, paste it there, identify what you need or not need, and you can define your list based on the concepts IDs. You just have to know a little bit about, in this case, OMOP CDM, because concept IDs in OMOP stored only on SNOMED level. So you would have to define them as SNOMED, and then you will have ability to define them as the concept IDs. You can define based on the code or the name and descriptions of the diseases in this case. And you can define any medical condition vocabulary. So meaning if you specify by name, you can search list of the items within any medical conditions vocabulary. So this is relatively simple. Let's go to the next step is take a look at the drugs information. In this case, for the drug, we have listing of GPI codes. So that a person that was familiar with this information with COPD identifies that they find it much easier to work with GPI codes. And they enter the codes that allows them with an asterisk to extend. So everything that starts with 44201058 will be found within the list. And here is list of the drugs that have been found within those three definitions. That's what's have been mapped internally within OMOP to RxNorm. So OMOP stores information in RxNorm format, and we, behind the scene, translate that information from GPI to RxNorm. Just want to make mention here is that you can also specify visit information of where you would like to define vocabulary to have access from. So you can say, I would like only inpatient people who are medical, who visited the hospital or went to the hospital, or outpatient or ER, or all of them, regardless of the type of visit that they had. Okay. Let's move to the next option there. So here is that we have different type of drug, and it's inhaler drugs. That's the definition of it, 4440 star. Now, this is drug have to be excluded one of the type of the drug that exists within GPI. So you can see the structure here is include as a label 4440, but exclude specific drug. And the definition of exclusion is, here is exclusion, and I just specify not exclude. That's all that's needed there. So I have two definitions. One says 4440 of GPI, and then exclusion criteria, anything that will be defined within this list will be excluded from the list needed there in the prior query. The next one is a little bit different. It's a definition based on Rx norm, based on the drug names. So you will see that in most cases I might not know what the codes are. So I will go to Wikipedia or some other resources and I will start searching based on the drug names. And I can list them all out, put them on the list, and identify what it will be translated to within OMOP CDM. That list can be modified and you can create very comprehensive or put exclusion criteria as you need there. The only difference we selected based on the name and description. So anything that contains definition of unifill within the data that we have for the name and descriptions, it will be found. In case of OMOP, for people who are familiar with OMOP structure, we are searching in this case only on the concept because we define as Rx norm. But if you will specify any drug vocabulary and will do search, it will combine information from source to concept map and in case of CDM5 relationship that goes to Rx norm. Okay. The next one is, if you'll notice that we defined relationship between ICD-9 code and drugs, procedures, observations as or, meaning that there is a relationship is inclusive. So give me all the drugs, give me all the procedures, give me all conditions and observations that will fit in within this criteria, and that will be defined as something that we will be included as COPD definitions of the disease for the patient. For the procedures, very similar. We have list of the procedures. We search them by name. The only difference here is that we are performing search on listings there that have a name in any vocabulary. So it will find carbon monoxide diffusion and so forth, all the kind of tests, procedures that's being performed on the patient that can be identified as COPD. And the second one is CPT specific codes that we will have. So that's also translate and maintain internally as a CPT code because CPT is a primary concept within OMOP. So, but the user doesn't have to know that. So they just enter whatever information that they have available to them, and they will be shown that information only to the extent that they need to enter. The last one is observation. Is we have list of LOINC codes that translates also maintained within LOINC of the system, and this information just based on the code for the LOINC. There is a number of different observation vocabulary that's available for the users to select. And we try to make sure that we have all of the ones that people translate their data to on observations, procedures, drugs, and conditions to be listed so that we would not miss any information based on the data that they have. So this is, if you'll take a look, this grouping corresponds to COPD definition. But in most cases, what we need is we have to identify when is the first onset of the disease. And the first onset of the disease, in this case COPD, is what we call index date. So index date is first time a CD9 condition or drug or procedure or observation have been recorded. So that will be marked by the system as an index date. We also can specify clean period and follow-up period. What that means is that we can identify within patient's records information that we have information about the patient for 120 days prior to the index date, so we have observations available to us, and at least 100 days after the index date of the disease indication that we have within the medical records. This gives us information that we are not seeing, like if you will say set up clean period to 0, we don't know if there was patient records just appeared and there was no prior information were available about the patient. Maybe the patient had the disease long before that, but we don't have any kind of indication because we didn't have any records about that patient. The next thing is that I would like to show is definition of demographics. Demographics is a little bit more graphical because we can actually choose range of years that we want to, or patient age that will be selected, and you can enter directly into the field itself, or you can just use a slider there. We also define if gender, male or female or all. We can also select specific race information, and here it fits in within the structure of the data death information, because it's sort of like definitions of we selected as part of the demographics. It should be very simple and very intuitive for people to select individual type of demographic data. So with this, we will move on to the next one. And next one, I'll just jump to measurements. So CDM4 did not provide measurements as a separate table. It started appearing in CDM5. And measurement tables are height, weight, BMI, blood pressure, systolic, diastolic, some other information that's available, that's measurable information. So we define measurement in such ways that it can be identified regardless of CDM. So if you have CDM4 or some other CDMs, you potentially can go in and identify this information within your data. You don't have to know that it's somehow structurally they're different. In this case, we define its height and weight information, it's just regular sliders. And if you'll notice on the right, we have option to select inches or centimeters or pounds and kilograms for the weight. And the reason is that we don't want people to know what is in the data, how the data is being stored. Is a ETL or a process that's created data set stored in one format in inches and pounds for American system, and then some European data that you are working with has kilograms and centimeters. We don't want the situation like, what was it, a couple of years ago, Mars lander crashed because some people measured in metric system, some people measured in American system, and they miscalculated landing there. So this kind of situation should be prevented as much as possible. The other thing is that we provide coloring for blood pressure and BMI information. So if you'll take a look, this light green information, it's indication of low BMI and blood pressure. Green means normal, yellow means elevated, and then very high for red information. But most of the people don't know exactly what the value is, so we try to simplify the process. So if you'll click on the question mark, just want to point to the question marks that's available, you can see information about BMI in this case. So you will have information about what is normal, obese, underweight, overweight. There is another caveat to BMI. There is a different classification for children and adults. So we provided for children information so you can select which ones is applicable if you're selecting children or teens, so you can calculate which normal will be within your range of days of the age of the person. Similarly for systolic, diastolic pressure, and smoking. Smoking in general contains tons of concepts within different vocabularies, within SNOMED, Loing. I believe I counted at one point about 500 of them. So if you have 500 definitions and you don't know what's in the data, it will take you considerable amount of time trying to identify what defined as a smoker, non-smoker, ex-smoker, and never smoked. So we try to make it simple and saying, okay, we will provide you very simplistic way of choosing type of smoking information. But if you want to do a little bit more complex for specific codes, you can still do that. We do not preclude you from that. But this gives you information of how we divided information. And on smoking, we give listing of definitions, what we consider to be smoking and non-smoking and ex-smoker definitions there. So you can verify, and if you see any kind of mistakes, please let me know and we will fix those. That will be a relatively easy change to the system. So this is measurements, and I just showed smoker is the same thing. The reason why we separated smoker and obese, we wanted relationship of or between them. So it's either person smoked or obese. If we would have grouped them together within a single definition, the relationship will be and, meaning the person smoked and they have BMI, high BMI. And within comorbidity, we also define that comorbidity, we have to indicate smoker or obese person that have to be 30 days prior to indication of the disease or 30 days or within 30 days after indication. So we'll know that at the time of index date for the disease, the person either obese or a smoker that we have. This is it. This is definition. So what do we do with this information? For one, we can export this information to XML. And exporting to XML, we'll just put the file, and it will create an XML file, quite open. You can see the full definition that we identified in our structure that will be stored in XML format. You can then take this XML file and give it to someone else and saying, you know, I want to run this study against your data with no modification. So the person in this case will import the data, choosing the file. You can also export and import to create a copy of your study. So you can say, okay, I will create a study with chronic COPD for male age 60 to 85. I'll have another study that will have different demographics or slightly different information there. So you can create numerous set of studies for yourself. We also provide SQL for the whole study definition. So you can go and see the whole glory details that nobody wants to see, frankly, including me, even that I spend so much time using SQL language there. It's a very boring type of task, but it provides you with information of how the study definition is going to be done for this specific language there that we chose. So once we define the study, what do we do with this? We'll go to tree execute. And this one I just executed against GE. And by the way, this study builder tool, right now we are putting together and will provide for users of within IMEDS lab. So all the IMEDS lab users will have access with the data that we have there. That means that if you didn't sign up for IMEDS Lab yet, please consider this. There are additional tools that will provide you with need to look at the information differently. So within COPD, we have, I just executed this one. Execution takes on our system about 3 to 5 minutes. So I'm not going to execute right now, but I'll show you with another study in a second there. So we have people with BMI, 242,000 people, smokers, 249,000 smokers within the data. Total comorbidity with an index date is lower there because we are taking into account that the person have to be within 30 days of index date. If you'll take a look at the drug procedures and conditions and observations, there is no observations because the data that we looked at, GE in this case, did not contain those observation codes. But there is 40,000 procedures, 208,000 definitions of the drugs, 351 conditions for total, because of OR indications here, is 553,000 people. And if we will take a look at the people who are within medical conditions with demographic limitations and comorbidity, it will come up to 100,000 patients that we can work with. The thing that we can do with this, one thing is we can export this into a document. And you can see Word presentation of that information of the definition. On the right side, you will see what are the value counts for execution against GE of the one that we are looking at. We can also look at the graph, and I'll jump into age of index date. So this is very similar to Odyssey presentation of Achilles type. We did plagiarize. I will be frank about the, we looked at the Achilles, and we just selected demographics information on that. And with some modifications, specifically age at index date. And so it has information about population by gender, population by race, but also information about age at index date. How old was the person at the time of the index date? Okay. Next thing is that I would like to go in and show you the graph of what is definition of the study sometimes looks like. And this was taken from PhenoKB website. So a phenotype knowledge base website contains open source information about different phenotype definitions. So I selected one for diabetes phenotype, and it's relatively simple, and we'll create a study using this definition. So what is phenotype definition for diabetes? Does it have diabetes code, yes or no? If it doesn't, you have to have 2 tests. Both of them have to be present. If it does have, you have either one of those tests available or a list of the drugs that will be created. So what we'll do is that we'll start with tree builder, new study, and we'll create diabetes. And you can select CDM type, CDM version. Right now we support only OMA, but we will be working on other CDMs also at some point in the near future. So we define the diabetes. Now we'll create 2 nodes, title nodes. We'll create absent diabetes, ICD-9, and we'll create another node with diabetes, ICD-9. Diabetes, I can only type. One thing that we want to mention here is that, actually, let me just delete this too quickly. one thing that I forgot to do is I'll create this as an index node because that's how it defines. So it's got to have the top level as an index node. And then I'll create my two titles with ICD-9 and another one, no ICD-9. Okay. With no ICD-9, we have two definitions. So if you'll take a look back, so we have index date definition with ICD-9, and without ICD-9. Okay. Now within no ICD-9, we have two items again. One is called lab. One will say definition of exclusion of diabetes. Okay, and the exclusion will be value of not. So meaning, give me the lab data but excludes diabetes. We will define medical condition of 250.x for ICD-9 code. And you can see there is a list of different ICD-9 translates to different type 1, type 2 diabetes. For the lab, something that I haven't shown you yet, but we'll go into that, we can define lab information. So we created a number of different labs panels. This is blood, urine panels, and you can do it yourself, additional custom ones or existing for the group. In this case, we'll have diabetes tracking panel. So within glucose, we'll have 200 value. If you'll take a look at the graph again, it's 200. It's actually EHR panel diabetes. Yeah, because we're going to look at the EHR. You can combine them both. 200. And the second one is just existence of it. So meaning that both of them have to be present within the test. That's how it's been defined. And with ICD-9, we will add also two nodes. We'll have diabetes, and we'll have another node, drugs or labs. So for diabetes, again, medical condition for 250 star for ICD-9. It just will be, you can define without specifying ICD-9, just will be a little bit faster if you know definitions. And we have to change here is we have to make it and because they're saying if it's not definitions of ICD-9, then you have drug or lab information available. And we'll say, in this case, drugs. And another node for labs. So the structure starts to look familiar now. Within the drug, we select list of the drugs. And I don't want to bother you with typing in all these long names because I would never remember them. I'll just copy them in here. And within definitions, there are names, so any drug name. But we also want children of ancestry. So this is group of the drugs, not necessarily drug itself names. So if we'll take a look at the results, this will be showing list of the drugs that are associated with all of the definitions that we have. So lists can be much longer than would be otherwise. And for the lab, we're almost done. We'll select the HR diabetes again, and we'll have 200 again. And because it says greater than for hemoglobin will have 6.01. And the relationship is OR, meaning that either one of those two can be present. We are done, So this took all the way to about 10 minutes to define the study. Now, what we will do is we're executing this study, and as its results start showing up, it will start calculated. The results start showing up on the screen. And you can see that we have information about lab, exclusion diabetes, and they'll start popping up. So as it executes, you understand what's going to happen there. We can discuss this, so we can open the mic and you can start asking me questions about the tool, and any kind of comments will be greatly appreciated.
Thank you so much, Mark. Very cool. So what we'll do is unmute the entire group. If you can keep phones muted on your end still, that would help us with the background noise. And then just feel free to announce yourself and ask Mark any questions you have. So just give us 1 sec.
The conference has been unmuted.
All right. Any questions?
So can you comment, Mark, on the availability in the lab, and how do I get to that URL?
We are putting it together, so we will be announcing for the users within the lab shortly, and we will just send the email to everyone once it's available for people to access.
Hi, this is Nancy from Amgen. Just a quick question. You generate SQL, and I'm assuming that SQL is running against a Redshift or traditional RDBMS environment. Do you have any indication of how that SQL will work against a Hadoop environment?
No, frankly, we didn't test it out. We have some plans to try it out, generating SQL against Hadoop or some other environments that we didn't try it out. We tested against Oracle, Postgres, SQL Server, and Redshift so far. It just so many things that we can do all at once. We will spread out the schedule, put together a schedule of development as we move forward.
Great.
And we'll try to publicize that.
Thanks, Mark.
Mm-hmm.
Any other questions?
Hi, Mark. This is Christoph Lambert. I think this is very nice. The next thing I'm thinking of is, okay, so I've defined a cohort. How does pulling information at different time intervals get done? If I ultimately want to create some sort of a table of occurrences or counts of events or stuff like that, is there something for that?
Well, there is so for one, you have saved cohorts. What it means is cohort is going to be saved on the database of list of the patients and the information. And we are planning to expand that to have ability for people to have a viewing mechanism of the saved cohorts as well as the time frame associated with each individual saved created cohort information. So some of the things you're absolutely right. So it needs like a time period information that can be viewed over.
Well, I guess I'm saying, okay, you've abstracted nicely away, say that a clean period and a follow-up period. But so now suppose I want to say, okay, in this clean period of 120 days pre-treatment, I'd like to know which comorbidities were present. Right, and I want to move that into sort of a next stage of analysis or something. Is this going to help us get there? I mean, obviously it gets us sort of a rough cut of here's how many patients satisfy our criteria, but then I'm thinking of a finer granularity of now I want to see what goes on in those time intervals.
Right. So what you describe is, in this case, similar to comorbidity that we defined within the COPD. I think if it's not, we can talk about this. So in this case, you can say comorbidity have to occur within the clean period. So if you will specify clean period, it means the comorbidity have to be within that period also.
Okay. Well, and I guess what I'm also asking is, like I'm looking at, within IMEDS, I then want to analyze individual patient data, and then do some sort of aggregate statistics, or I'm obviously developing methods for correcting biases and so forth. So I'm I've had to build all this sort of type code and deal with it, like you see, preaching to the choir on no one wants to look at that SQL to generate the query. But then I've had to write all sorts of code to essentially aggregate event types and so forth. And I'm just seeing that the great stuff you've done on finding the query. How do I? But maybe we could talk offline. But really,
yes.
Nice work.
So one thing that I just want to mention is, just because we provide in SQL, we are not claiming that we have covered all the bases for definition of the study. Far from it. So there is some things that people might want to do, and I assume that they would want to do outside of information here. So for those cases, and hopefully they will be, it will provide you initial boost to get the SQL and to get the study predefined, at least initially. You can extend your SQL, or you can perform another exclusion criteria within the data that we did not provide it yet. So you might say based on the drug cost or some other information that does not exist there yet, that we might want to extend within our queries or for our specific study. That obviously we could not satisfy 100%. We are looking to satisfy maybe 90%, 95% of initial work, and then maybe 5%, hopefully even less, that people with some technical background will take a look at saying, I need something that the tool does not provide. And that's where I would like to concentrate on.
Nice. Thank you.
I have a question. This is Wojtek about the version 5 for the measurements. You showed an example where the numerical values for hemoglobin A1C are needed. So G version 4 versus G version 5.
We're having a little bit of problems hearing you. Could you speak up a little bit? Thanks.
So the question is about version 4 and version 5.
Yep.
How is it tackled? And actually, a side question, like, is there a G version 5 in the collab? That would be excellent.
Right now, there is no version 5. We start looking at that conversion to version 5 within the IMEDS cloud, but it's not available yet. So we are testing the Cohort Builder, Study Builder tool to run against both CDM5 and CDM4, and obviously it generates different code, different SQL for each one of them. We actually looking to produce ability for people to go from version 4 to version 5 queries, so they can convert from one to another by just performing definition, and then go from one to another, because some of the options available in different CDMs and different versions that might not be available in some other ones.
Hey, hi Mark. This is Rajender.
Hi.
So thank you for sharing this. This looks pretty nice. One question. So right now you are able to create the cohorts and studies on the basis of observational data. So is there a plan to, does it also support the research data, like clinical trial data or the public studies data?
So it's right now the plan, at least the current plans are to support only CDM structured data. So we are not trying to create any kind of data that might be in existence. So because then we would have to code in SQL and operations in the background to know all the different structures where the data resides in their definitions. We are planning for now to support OMOP, CDM4 and 5, and in the future, Minisentinel, Picori, if we have some ability to do that. But unstructured, non-CDM data, it's obviously much harder to do, and it's not consistent, unfortunately.
Sure. I have one more question. Right now, the tool you have demonstrated, it generates the SQL and, it stores all the studies and their results. So does it also provide some sort of, web services so that we can take the data to, for subsequent analysis and maybe the tool of choice like SAS or, R or something?
We are looking to extend some web services potentially. It's just initial stages right now to define what web service is going to be. The list, with this kind of tools, unfortunately, the list is quite large of what can be done. So we have to prioritize and identify what is the biggest bang for the buck for people to have with this kind of tool. And so one thing is to include as many people as we can to utilize this kind of tool. The other thing is to how do we integrate with other applications that people are developing over time and to make it interoperable. So for that, we try to do like import and export abilities, but that's what I provides an easy way to communicating of transferring the study, execute them somewhere else. But it's obviously web services would be a better solution in some cases.
Sure, thank you. I'm looking forward to play around with it when it is available on IMEDS.
Okay.
Thank you.
Hi, Mark. This is Hugh.
This is Patty St. Clair from the Schaefer Center at UST, and I was wondering if you could talk a little more about what actually is exported to XML. Do you get individual patient lists of IDs or that you could use to pull data from the database, or are you getting counts of the? I'm just trying to.
Yep.
I'm reading XML.
Yeah, here's XML. XML is only definition of the study. It doesn't have information about the patient. It doesn't have information about which data sets you're going to be using in the future for this definition. So you can freely transfer, just saying, I'm going to be using a study with this ICD-9 codes, with such and such procedures, drugs, and you can see it's all open. So it's there is no proprietary information. You don't need IRB meetings to transfer the definition of the study. Even the document itself, the one that's when you execute the listing here, it does not contain information besides summary statistics of the information there. So even that summary statistics you can share between the groups saying, I have so many people with ICD-9 conditions for COPD, so many drugs, but it doesn't go to the patient level. Only when you go to save cohort, it saves information based on the specific patient record, and that's internal to the system that's been executed. So it's not, nothing goes outside from the system within its incarnation here.
Okay, so you would, if you did want to actually do further analysis on the group that was selected, then I'm just walking through what one would do. You would execute the SQL that was generated and then work with that group. Is that roughly?
Well, you say Cohort, it will create that listing for you. You don't have to execute SQL or anything like that. You just press this single button and it will start saving the cohort, and then you just saying, I want only patients within this cohort to be available to me for my study.
I see. Thank you very much.
Yes. Thank you.
Hi, Mark. This is Hugh Kawabata from BMS. So
Hi, Hugh.
one plea I would make is, you know, in the criteria for your conditions or drugs, to take time into account, because very often when we get project definitions, it requires, you know, that, for example, that there be 2 ICD-9 codes within 30 days, or there would be a diagnosis and a procedure within a fixed period of time. So my plea would be for adding time there.
Yeah, absolutely. So this is done with, the first one becomes an index date, and then you will create another node with exactly the same code saying that it's have to be 1 day after the index date. This will give you ability to define there's more than once the disease have been defined. So you will say, I have 250.x, this is my index date, and then another one will say, and have to be from that index date at least 1 day another diagnosis of the same disease that exists.
Okay, thank you.
What it doesn't provide in the simple way, and we actually looking is, if someone will say, I want to have at least 5 diagnoses or 5 intakes of inhaler, that's usually like, for example, for COPD, we didn't include some of the inhalers because there's have to be 5 of them or more. That will constitute COPD. Otherwise, this will be asthma. So those kind of things we are looking. There is a way to do that, but it's just much harder.
Yeah, I've seen some user interface use a kind of a visual picture to represent the time. You know, so you can, like you have those sliders, right? You have a slider for the days between and stuff like that. That would be nice.
Yes. We will do that next. Hugh, I would like to hear your opinions there, and we'll try to implement as many comments as we can in the system.
All right. Well, thank you. Good work.
Great. A couple more minutes. Any other questions from the group? Okay. Well, we covered a lot of material today, but Mark's always available for questions if something's come up. And if you don't have his email, reach out to me or Christine, and we'll make sure you get it. Mark, just for a general timeline of release for this, it sounds like we're still doing a little bit more testing. Are we thinking 2 or 3 weeks before we can send an email out?
Yes. So we will notify all the people in the lab, and if you have any questions about that or any other things about the study builder tool, let me know, send me an email, and we can do it, another discussion if it's needed there. If the people in the lab need some training or have some questions once we release, I'll be more than happy to provide them the support.
That's great, Mark. And we'll post this webinar up on our website like always as well if you need to review it again. Okay, well, thank you, Mark, and thank you, everyone on the line, for joining us today. We'll get the appointment out for the September call in the next few days or so. And that's about it. Have a great weekend, and we'll talk to you guys soon.